Hello, and welcome to the fifth session of this course. In this lecture, we will explore how verifiable credentials are issued. This lecture is part of the foundational series designed to help you understand the basics of the OmniOne OpenDID platform. If you follow along step by step, you'll be able to grasp the essential processes with ease. Let's get started. VC issuance is the process where an issuer digitally certifies a user's qualification or attribute. For example, Korea University may issue a digital diploma to a student named Hong Gil-dong. This process involves user authentication, data verification, and digital signing, which results in a verifiable credential. In other words, after confirming that the requester is indeed qualified, the VC is issued in a trustworthy digital format. This lecture will focus on the core aspects of VC issuance. For detailed information, please refer to our GitHub pages. You can access the link by scanning the QR code. Before we dive in, let's review a few basic concepts related to VC issuance. First, a VC stands for Verifiable Credential. It's a digital certificate that proves some kind of qualification or identity. Next, an issuer is the entity that provides the VC. It could be a government agency, a university, or a company. With these basic terms in mind, let's now walk through the process of VC issuance. In the OpenDID platform, VC issuance consists of two main stages: preliminary procedures and issuance procedures. The preliminary procedures involve planning and registering the necessary information ahead of time. The issuance procedures are where the actual credential is created and issued. We'll take a closer look at each step next. Let's begin with the preliminary procedures. As the name suggests, this phase covers planning and registering the required components for VC issuance. First comes the planning stage. A consortium of issuers comes together to define the claims and schemas to be used. Of course, an issuer can also operate alone. For example, a consortium of Korean universities may define a common claim and schema for issuing digital diplomas. Next, a plan manager is designated. This is the person or system responsible for managing the VC issuance plan. For instance, if Korea University has a diploma issuance service, that service becomes the VC plan, and the plan manager oversees it. A representative issuer may also be designated within the consortium. This is optional and based on need. Then comes the registration stage. Here, a listing entity is introduced. This entity is responsible for registering and managing VC plans and related information in the system. Think of it like a central platform managing a list of diploma issuance services from multiple universities. The defined VC plan is registered by the listing entity, and authorized issuers are also designated and registered. Once both the planning and registration steps are completed, the preliminary procedures end. And we move on to the issuance procedures. Here is a summary of what we just covered. So, to quickly recap the preliminary procedures: first, you define the claims and schemas. Then, you assign a plan manager and, if necessary, select a representative issuer. After that, the VC plan is registered through a listing entity. And finally, the issuer who will actually issue the VC is registered. Next is the issuance procedures, where the actual credential issuance takes place. We begin with the initiation phase. There are two types of initiation: issuer-initiated and user-initiated. Issuer-initiated means the process begins with the issuer, who already has the user's information. The issuer generates an issuance offer and sends it to the user. For example, Korea University sends a push notification to Hong Gil-dong's phone offering a digital diploma VC. That's issuer-initiated. User-initiated means the user searches for and selects a VC plan directly in the app. For example, Hong Gil-dong opens the app, searches for Korea University's diploma issuance plan, and initiates the request himself. After this initiation step, we move on to the actual issuance process. In the issuance stage, the user and issuer carry out the credential issuance based on the earlier mapping. The process starts when the user submits an issuance request. Next, the user also requests an issue profile. The issue profile includes metadata about the issuer, schema details, and how the issuance process will proceed. Through this profile, both the user and the issuer clearly understand the encryption algorithms used and the attributes in the VC. Once the request is submitted, the issuer performs user authentication to confirm the user is eligible for the VC. Finally, the VC is issued and securely stored in the user's wallet. Here's a visual recap of the issuance process. In issuer-initiated issuance, the process starts with the issuer, who already knows the user's information and generates an issuance offer. This offer could be delivered via QR code, push message, or email. In user-initiated issuance, the user searches for and selects a VC plan directly in the app and proceeds to request issuance. As you can see, the initiator, method of searching VC plans, and how user information is managed are all different between the two. Here's another diagram, this time focusing on the actual issuance procedure. Following the initiation step, the issuance process begins. First, the client sends a request to initiate issuance and asks for the issue profile. This request is relayed to the issuer via the touch, and the issuer sends back a response to the client. Next, the wallet sends the actual issuance request, rather than the client app directly. That's because the VC must be securely transmitted and stored, and the wallet is designed to ensure end-to-end security. The request goes from the wallet to the issuer, who then verifies the user's eligibility and issues the credential. That completes the issuance process. Now let's take a look at the components of a verifiable credential. A VC typically consists of credential metadata, claims, and proof. Credential metadata includes information such as issuance date, expiration, and schema reference. Claims refer to the actual attribute data. In the case of a diploma, this might be the graduate's name, degree, and graduation year. Proof includes the cryptographic information needed to verify that the VC was issued by a trusted issuer. For example, the issuer's digital signature is included here. When the proof is successfully verified, the recipient knows that the VC is genuine. Now, let's take a look at some real-world examples of how VC issuance works in everyday life. Let's start with user-initiated issuance. For instance, a student opens their school app and manually requests a digital student ID. In this case, the request begins with the user, who directly interacts with the wallet or app to initiate issuance. Next is issuer-initiated issuance. For example, after passing a driving test, the licensing agency sends a QR code. The user scans the code and receives the VC. In this structure, the issuer prepares the VC in advance, and the user retrieves it using the given code or link. That wraps up the 5th session. I hope this lecture helped you understand the VC issuance process in the OpenDID platform. In our next session, we'll explore how verifiable presentations are submitted. Thanks for joining me today, and I'll see you in the next one.